Okay, good morning. Welcome to the class. I just want to prepare the video now offline so that we can have it more, have a clearer video that will be more beneficial to us. Alright, so recall that I sent you the data which we used during the live training for demonstration. So all I need to do now is I will just go over to the file or folder where the data is and prompt for it. Okay, that's what I would do to open it, but then it appears I've already opened it before, so I'll just go over to it. Practice data regression. So this is the data. And then one of the things we'll first of all do, as we said during the class, you would check the linearity based on the assumptions of linear regression. I must quickly remind you that there are several types of regression. You have the most common ones being simple linear regression, and then multiple linear regression, under each of which there may be some others. And I encourage you to do a little self-study to acquaint yourselves with all other forms and how they are performed. And then recall also that I have already sent you a complete textbook written by Juliet Pallant, a document or a book that has been very useful to me all these years. So there are some assumptions that are observed, or that should be observed, when multiple regression is being performed. The first is normality. Normality is checking how your data seem to cluster along a straight line, assuming you are using a scatter plot, which we are going to use now. So you explore your data for normality, and simply to do that you click on graphs, you click on legacy log, dialogues, and you select scatter stroke dots. Now when it comes up, you pick simple scatter plot, and then you click on define. Then you move in years of experience, last year's sales as your dependent variable, which is expected to be on the y-axis, and then your independent variable, which is for instance years of experience, into y-axis, and then you click on OK. You wait out computer to present the analysis. Okay, good. Our data has come up. As you can see, it appears as if our data looks like one that has normality. So one of the assumptions is already taken care of. Then, in as much as you did not find any of the dots drifting too far, maybe around this area, from if a straight line were to be plotted, then there may be some element of outliers, numbers that shouldn't be in the list. However, they seem to still be fitting somehow in the data. So this is what you do to check whether your data is normal. Now, having taken care of that, next we need to do is to go back out to our data and begin to see how we can carry out analysis. Now, first of all, before we go on, I would like to remind you that every linear equation has the usual formula which we all learned from our basic mathematics class, where y ax plus c is the equation of a straight line. Now this is a simple linear regression. However, we may need to just substitute the data, the parameters of this equation, to have c to change to b. Now if we are to define the items, y is our dependent variable, x is our independent variable. Okay. A is the slope of the straight line, and B is the intercept, which represents our C, whatever letter is being used, but we're using a B. B is intercept on y-axis. Okay, with respect to our data, y being the independent variable is sales. Being the dependent variable is sales, and the independent variable is either years of experience, or education, or both. Education. Of course, the slope is just the slope, and y is just a b is just a b. We may insist that the computer should record this as a small letter. Okay, now this is the equation that we'll be handling for simple linear equation. So we're going to be making substitutions into this formula. So let's go back to our data, practice data regression. Here we are. You are going to run a simple linear regression in order to get those parameters, and then we'll go ahead and do a substitution. Now, to do linear regression, both linear and multiple regression is done almost the same way. So you click on Analyze, scroll down to Regression, pick out Linear. Then you have your dependent variable in this dialog box. You have independent variable. So our dependent variable, I've told you, is sales. We're dealing with last year, so last year sales. And dependent variable is independent variable is years of experience. You just go ahead and click on OK. Now you have your regression summary. Model summary shows that our R, the predictor, which is years of experience, accounts for almost 0.99% of the changes that could be recorded. And if you are to look at the ANOVA table, assuming you have a hypothesis that states that years of experience does not influence sales, that particular hypothesis would have been rejected, meaning that years of experience influences sales among the staff. Okay, so that is how you interpret the result of your linear regression. But for now, we're not interested in that particular interpretation. We want to build our model. Alright, so to do that, you pay attention now to your coefficients table, and then specifically under the unstandardized coefficients, you pay attention to B. Now 1400.808 is our constant. That stands for B in the formula which we have developed. So I will just go ahead and copy these two and then move them over here. Now the formula will now be y. The new formula we're building now is y equal to A is alright, our A is 1816. So this you say times x. Alright, so plus 1400 point, copy now, and then you paste. Alright, so this is the formula of our equation. So if you are now asked to predict what will happen next year, you could now use this formula to predict. Right, to do that let me go ahead and copy. To do that, you are asked to predict the sales for the incoming year. So predict this year's sales. Like we discussed in the class, we said banks could use this kind of method to set targets for their staff. So to do the prediction, you click on transform, click compute variable, and you click control compute variable here. Let's go ahead and type simple for simple regression, and then we can go ahead and paste what we have copied earlier. All right, okay, now there's an additional 1 year experience to now predict what sales could be recorded. So this is it. You go ahead and click OK. When you go back to check your data, the computer has done the calculation to tell us the likely sales of the staff of this particular company. Alright, so you will also go ahead to add the dollar sign to indicate that you are dealing with monetary figures. Click numeric, click dollar, select the highest possible one, click OK, go back to your data view. Dollar is now attached to the figures. You may do the alignment to rhyme with others. So this is what we have. That is how you predict this year's sales when years of experience is juxtaposed. Now, what if you are now to carry out multiple regression in order to establish whether education, level of education, and years of experience together could influence sales? Now, before you do that one also, you need to build the model. And the model, where you have such a case, the model is, for instance, z equal to ax plus by, then plus c plus c. Alright, so this is how it's done. That's the formula. And in order to interpret the formula or the model, we also do well to say that in this formula, and give it a little space, I could now color it green so that okay, now in this formula, of course, Z is the predicted sales, which is also the dependent variable, which is sales. Okay, then you have A is the y-intercept. A is the intercept on y-axis, because we're having two lines, where you have B is the intercept on x-axis. Intercept on x-axis. Then our C is the constant. C, constant. All right, constant. Okay, so we now try to fit our figures in the, and of course we have forgotten, let me add that x is x is the independent variable 1. Let's say years of experience, and then y. Okay, so this is it. The formula is clearly this now. We can just replicate it here. Then we'll go to the data and perform the analysis. Following the same method, click on analyze, go down to regression, select linear, and then add education to this mix. Okay, add education and click on OK. Alright, after that you come up with this table, and you may do well to copy this. Okay, move it over and build your model. So Z is equal to the value of years of experience, that's y-intercept this time around. Okay, so okay, that's in this formula now. I think I should correct it here. So okay, constant is this first one. That's constant. Then the years of experience is A. Copy that and impute here, and of course introduce the multiplication sign, and then our B is this 50 point that we have left, and introduce multiplication sign. So this is the model for predicting the values. All right. Is the model for predicting the values. Now let's go ahead and predict what the sales will be if education is juxtaposed with years of experience to give to check for the sales recorded. So we click on transform, compute variable. You do well to click reset here so that you clear what you already have. We're going to use the word multiple because we are performing a multiple. We have performed multiple regression. Multiple. Good. Then here we paste our model. Go to the where we have designed the model and copy it, leaving out first. So Z now is not the multiple. So paste this here. X is years of experience, and that will be the experience year 2. Okay, because we're talking about this year's sales prediction. Then Y will be education. Move education into place, and you have that. Now you go ahead and hit OK. If there's a problem, the computer will let you know. If there's no problem, the computer will still let you know. So now you can see that it has generated the figures. So when education is juxtaposed, you see that there seems to be a slight increase in the sales. So here too you will do well to change the data type to dollar and to indicate that it's a currency, has to do with the figures are monetary in nature. And then you may also align. Go ahead and click on OK, and here you go. You have the predictions for the year if education and years of experience are put into consideration. Okay, then there is another thing that could also be done with multiple regression. When you want to do introduce bonus, please take note that this sales is the actual sales that this salespersons whose sales ID are here. These are the sales they actually sold, but this was the prediction. This was the prediction based on their years of experience, and then this is based on if the education is brought into the mix. Now, if you want to, often, for instance, we hear Nigeria banks will set the targets for their staff, and some of them who fail to meet the targets are often sent away. But of course, those who surpass the target are also rewarded. So assuming you want to come up with a reward system to build and say, okay, those who surpass their targets will be rewarded in a certain fashion. This is how to do that using SPSS. So now, assuming you determine that you are going to reward your staff $1,000 if they surpass their targets by a certain amount. Let's say if they surpass their target by $2,000 or more, you are going to grant them a bonus of $1,000. So how do you do that? You go to click on transform, click compute,
clear this one you already have, then type bonus to see who and who will qualify for the 1,000 naira. So this is the $1,000 you have determined to reward anyone who is able to surpass their targets in the actual sales by at least $2,000. So but then you know that you have to now come up and say you set a condition, and that is where you now need to click on if. And after clicking on if, the if cases, you will click on include case if it satisfies the condition, and the conditionality will be that you will say if this year's sales, or is the actual sales, is when you subtract, for instance, the multiple regression results from it, and if this result is greater than or equal to 2,000, then it should include the case. This means that if somebody surpasses his target, this target, you could have also used simple here if you are interested in just years of experience, but this one carries both years of experience and education. So if somebody exceeds his target by $2,000, he will get the reward. So you click on continue and you click continue. You want to see now who and who qualify for your bonus. So you can see now that it's not everybody. Case number 4 qualifies. Case number 17 qualifies. If when we scroll down again, see that case number 46 qualifies for bonus. So this is how you do that. And of course you may also go behind here and say okay, change this to dollar, and select here and click OK. Also a line left for uniformity's sake, not that it has any impact on the results. So you can see that you know who and who is qualified for bonus. The machine has done the calculation. Nobody has any reason to complain. So this is how you can use multiple regression, SPSS, to perform multiple regression, and as well predict sales. On top of that, determine who and who is qualified to get bonuses. Okay, now how about performing multiple regression itself? When you have a research where you have designed an instrument and you are checking whether one factor influences another factor, you could go to this file that I sent, survey serve, and allow me to delete these ones first. Sorry. Okay, so now this is the file that I sent you. Okay, so we're going to perform linear and multiple regression also. So the method is still simple. You click on analyze, scroll down to regression, and select linear. Then in this data, the dependent variable is according to the question, how well do two measures of control, that is mastery and poise, predict perceived stress? In the document I sent you, that will be found on page 146. Alright, so stress, total stress is our dependent variable. Then you are now interested in how total mastery, if you pick any one of them, this is mastery as independent variable, push it in. Let's quickly run that and see. But there are so many other things you may need. I think it's best we just do the two at once to save time, since we have already discussed it. Alright, so you move total picoes also into the independence list. Then you are now expected to click on ensure that method here is showing enter. Then you click on statistics button. Their estimate is already automatically clicked, but you have to also click on confidence intervals. Click on model fit, is already checked. Then you check descriptives, part and partial correlations, then collinearity diagnostics. Down this way, under residual, you are expected to check case-wise diagnostics, and then you click on continue. After this, you are expected to click on options, that's options, and then you are to click on exclude cases pairwise, which is already automatically selected. So you click on continue. Then you click on plots. You move z resid into y-axis, z resid into y-axis, and you move z spread into x-axis. Then down on the standardized residual plots, you select normality plot and you hit continue. Okay, then you click on save. Under save, you are to select under distance, you select Mahalanobis and Cooks. You click continue. Then finally you click on OK. Computer will run the analysis and begin to give you results. Alright, so here is the analysis. These are the correlations. Then these are the variable enter stroke removed. Then you have model summary. These two factors, the predictors, total picoes and total mastery, are able to predict the dependent variable, which is total perceived stress, by about 68%. So the model is in line. And you come down to ANOVA table and check. Okay, so as you can see, the sig value is 0.000. On a good day, that tells you that there is a statistical significance, alright, in that. So this is how you perform multiple regression. And then this time around, since we are not predicting, we are not that interested in the coefficients. Otherwise, if we were building a model, we could have made use of this to predict, to see where that will be. So for other details of interpretation and all other things, you will find that in the material I sent you. But if peradventure you are interested in checking the normality, you can see the